Hey everybody, okay, so now let's talk about integer exponents and scientific notation. All right, this might be a good place for you to start keeping like a page. So go to a clean page in your notes and put down, or you may already have rules of exponents and you might want to add this to it. But nonetheless, this needs to be in your rule of exponents, okay? And there's really two rules here. And I'm going to tell you that this rule right here is when the exponent in your numerator is bigger than the exponent in your denominator, okay? You have your base and then you subtract your exponents, okay? This rule over here is when your denominator is bigger than your numerator exponent, and then you have 1 over, and then you also subtract, okay? So wherever you have more of the exponents at, that's where they stay, and you subtract. This is our negative exponent rule, okay? It says that wherever your base is located, if it has a negative exponent, that means it does not like its location and it needs to move. I'm going to say this. Negative exponents don't have anything to do with the sign of your answer, okay? They are a movement only. Let me say that again. Negative exponents do not have anything to do with the sign of your answer. It does not make the answer positive or negative. Sorry about that. Macy likes to get in the videos sometimes. Okay, so like I said, negative exponents are a movement only. They do not make your answer positive or negative, all right? All right, so let's look at this one. All right, so on part A, we have 4 to the negative 2 power. Now you need to ask yourself, where is 4 located right now? Well, right now, because there is no fraction, it's located in the numerator. That's the default, right? So if it's unhappy with its location, that means it's going to move from the numerator to the denominator, and you get rid of the negative on the exponent, but you have to put something in the numerator, okay? And you don't just make up a number. It's got to be a 1 up there. It can't be a 0. That would change the value, okay? And now we can actually do the math of the 4 squared part. So this would be 1 over 16. All right, this is our final answer. Part B, we've got 10 to the negative 3rd power. Where is it located right now? Right now, it's located in the numerator. So we want to move it to a location that makes it happier. So we're going to move it to the denominator. Remember, I put that 1 up there in the numerator. And when you move it to the new location, it becomes happy. So we get rid of the negative on the exponent. And now we can do the math of the 10 to the 3rd power, which is a 1 with 3 zeros after it. There you go. All right, on these two, notice the location. This one, the y, is in the denominator, and it's unhappy with its location. So it's going to move to the numerator, and we're going to take away the negative on the exponent. So what about that 1? What do we do with the 1? Well, it could either stay there, doesn't matter, it does not change the value, but if you simplify the way it's written, you get rid of it because it is understood to be there, okay? So this is the final answer on that one. On part B, the 3 is unhappy with its location. So we're going to move it to the numerator, get rid of the negative on the exponent, and now we're going to simplify 3. And by the way, what about the 1? Well, that 1 is multiplying that. What happens when you multiply by 1? It doesn't change your answer at all. So here's our final answer. All right, for this problem, let's look at part A. We've got 5 to the negative 2 power. We've got 7 to the negative 2 power because remember, we've learned in our rules that when you have a fraction and it's raised to a power, that each piece inside the fraction gets raised to that power. So in part A, it would be 5 to the negative 2 power and 7 to the negative 2 power. But look, they're both unhappy with their locations. So we're going to swap their places. All of a sudden now they're happy. And now we can do the math. There we go. We're done. All right, let's look at part B. Do that in a different color so we don't get this mixed up. All right, so we've got negative 2x over y. All of this is raised to the negative third power. Okay, so let's see here. We're going to raise each piece to the negative 3 power. The negative sign out front is going to hang along for the ride. Okay, and by the way, that parenthesis, it really doesn't matter. So I can actually remove it at this point. Okay, now check out all these things that are truly unhappy with their location. The 2's unhappy, the x is unhappy, and the y is unhappy. So we're going to flip-flop everything around and take away the negatives on the exponents. And by the way, I'm going to go ahead and do 2 to the third power. 2 times 2 times 2 is 8. And there we go. There's our final answer here. All right, let's look at part A here. We have negative 3 to the negative 2 power. So this is the same thing as, let's see here, negative 3 in the denominator to the second power, but what goes in the numerator? A 1. Now, what is negative 3 squared? It's positive 9. There we go. All right, so how is this problem right here different from this problem right here? So how is A different from B? Well, believe it or not, they are very different answers, okay? So let's take a look at that. So we've got only this goes into the denominator. Of course, it doesn't really matter where that negative out front is. It's just going to stay out front, okay? It's just going to stay out right there next to that fraction bar, okay? We're going to move this guy to the denominator, take away the negative in the exponent. You can't leave nothing in the numerator, so we're going to put a 1 there. And now this answer is negative 1 over 9. Notice how I didn't move this with the 3. When there's no parentheses, the negative is not attached to the 3, okay? It's just telling us that our answer will be negative, okay? So the parentheses make all the difference in the world with negative numbers. Also makes all the difference in the world when our exponent is even. If the exponent's odd, it doesn't really matter. You can have parentheses or no parentheses with a negative number. Your answer will be negative if there's a negative sign, no matter what, if it's odd, okay? All right, now, in order to do these two problems, I'm going to erase these two. So you might want to hit pause if you haven't written them down, and just know I'm about to erase. All right, here goes. Voila, magic. Okay, so let's look at C. So I've got negative 1/3. The whole thing is raised to the negative 2 power. Okay, that means I'm going to take each of these and raise them to the negative 2 power. Okay? And by the way, I always like to assign my negative sign, I'm erasing it, because I like to assign it either to the numerator or to the denominator. But why am I not assigning it to both? Think about that for just a second. If I have a negative over a negative, don't I now have a positive number? Yeah, I totally do. So that's why I always take that negative sign, and it's just habit for me to assign it to the numerator, okay? And if it makes you feel better to write it like this, well, that's not negative 3, sorry. If it helps you feel better to write it like that, then write it like that. You can take the big set of parentheses and put it around the numerator and then also a set around the denominator if you want, okay? It doesn't change anything. All right, so now let's flip-flop these guys' places because they don't like their location, right? So I've got 3 squared, and notice I dropped the parentheses. That's because now they don't matter, all right? And then in the denominator, does this one matter? Yeah, totally, because that negative sign is attached to the 1. That means I need -1 times -1 in the denominator, okay? So my numerator is 9, and my denominator is +1, because -1 times -1 is a positive, okay? So now I have just 9. Now, I've noticed that some of you are putting, in your homework, like if you end up with a whole number and it's over 1, I've noticed that some of you are putting this answer on your paper. Keep in mind that if you can write something in a shorter way, you should. You should. 9 over 1 can be written as 9. Now, does 9 mean 9 over 1? Yeah, totally. But you should write it in the most simplest form that you possibly can. Okay? All right, let's look at D. All right, so on D, notice my negative is on the outside. That means that my final answer will be negative. Period. No ifs, ands, or buts, okay? So, and actually, here's what I'm going to do instead. I'm going to do and... Okay, so now we got to make them happy. Flip-flop their places. And now let's do the math. And there we go. Now we're done. All right, so let's take a look. Notice on these two problems, it's got the same numbers, but will you get different answers? Well, I think so, because notice right here, we're only raising the 2 to the -1 power. We don't raise the 4 to the -1 power. But over here, we take the product first, according to order of operations, and then we put that number to the -1 power. So we should get very different answers here, okay? All right, so let's take a look. So on part A, we will do 4 times 1 over 2. Okay, remember that -1 is a movement. That means that the 2 didn't like its location. And its location used to be on top. So now it wants to be in the denominator, okay? And what is 4 times 1/2? It is 2. So there's our final answer. All right, let's look at B. According to this one, in order of operations, we got to multiply the 4 times the 2 first. So we get 8. And then we have 8 to the -1 power, which is 1 over 8. Notice on this problem, my answer is not negative. The negative exponent means that it hates its location. It does not change the sign of my answer to be a negative answer. You're going to hear me say this at least 47 more times in this video. Actually, I don't know if it'll be 47, so please don't keep track, but it could be. So if you want to keep track, let me know. All right, let's take a look at this one. We've got x to the -6 power. I don't know why I circled the a. Anyways, it would be, on part A, it would be 1 over x to the 6th power. And that's the best we can do with this. We can't do anything else to it. On part B, we've got, remember, we've got a power raised to a power, so that means we have to multiply the powers together. So we've got u to the -12th power. And then we can't leave it with a negative exponent. It's not fully simplified with a negative exponent. So we've got 1 over u to the 12th power. There we go. We're done. All right, so let's take a look at all 3 of these. They're all very similar, but they will have very different answers. Okay, so this first one, only the y is to the -1 power. So that means the 5 likes where it's at. It's going to stay put. The 5 is not being raised to the -1 power. So we've got 5 that likes its location. It's going to stay in the numerator. The y hates its location. And we can put a little 1 there or not. But remember, we like to write things in the most simplified manner. So we're not going to write that 1. It is understood to be there. So that's it for part A. Let's look at part B. On part B, we are raising each of these factors to the negative 1 power. So 5 to the negative 1 and y to the negative 1 power. That means they both hate their location. And this is it. This is it for part B. All right, let's look at part C. Hang on, let me make some space here. There we go. We'll put part C down here. Now, we've got negative 5 to the negative 1 power. Remember, in our rules, we take each factor and raise it to the negative 1 power. And then we've got y to the negative 1 power. Okay, so in this case, our answer would be 1 over negative 5y to the first power. Now, where does this negative have to be? I get this question a lot. Does the negative have to be right there in the denominator? You know what? It doesn't really matter. You could write it like that. It won't hurt anything. You could put it out front. Or, you might hear my dog. She kind of grumbles. Or you could put it in the numerator, actually. It won't hurt it to be there either. All three of these answers are the exact same answer. All right, so these are all the rules that you've been taught with exponents. Hang on, let me try to blow this up a little bit. There we go. If you don't have these rules on a sheet of paper, you might want to, especially before you take a quiz or a test. It would be nice for you to have these handy. So, you might want to hit pause here because I'm definitely not going to read them to you. So hit pause and make sure you have them in one spot, or if you want to have them on a note card for the test, that wouldn't be a bad idea either. If we were in class, I would actually give you a sheet that has these rules on them. All right, so now we're going to apply all the rules at once. This will be fun. Okay, so on part A, notice we have the same base. Okay, that means that we're going to add our exponents together. So we get x to the negative 4 plus 6, which gives us x to the second power. That's it. We're done. All right, let's look at part B. Part B, again, same base, so we're going to add our exponents together. Y to the negative 2. That's not proper form. Proper form does not have negative exponents unless we're dealing with scientific notation, and we are not yet. So this would be 1 over y to the second power. All right, let's look at part C. We've got the same base, so let's add our exponents together. Z to the negative 5 plus negative 3. Which is z to the negative 8, which is 1 over z to the 8th power. And that's it for that one. Yikes, it's a hot mess. Look at that. All right, so let's multiply this. Like bases, we add our exponents together. So we would get m to the 4th plus negative 5, n to the negative 3 plus negative 2, which gives us m to the negative 1 power, n to the negative 5 power, and they both hate where they're living, so let's move them into the basement. 1 over m n to the 5th power, and that's it. All right, we've got a product to a power, and then we've also got a power to a power within this product. This one looks like a hot mess too. All right, so let's do 6 to the negative 2 power, and then we've got k, but we've got a power to a power, so let's multiply those together, and you get negative 6. They both hate where they're living. They're going to move, so I get 1 over 6 squared, k to the 6th power. And I can do this math right here, so I've got 1 over 36 k to the 6th power. That's it. I know what you're thinking. You're thinking, she makes this look so easy. Well, yeah, you will too after you do the same math 20 years in a row, like 4 times a year. So just keep in mind, I've had a lot of practice at this, and you're just now learning it. So be kind to yourself, please. All right, so we've got, on this problem, 5 to the second power. We've got x to the negative 6th power, okay? So 5 likes where it's at. 5 is totally happy in the numerator, so it's going to stay there. X is going to move, and we'll take away that negative exponent. Now we can do the math for the 5 squared. And now we're done. Okay, so let's talk for a second about scientific notation. Scientific notation is truly one of the only places where it's totally okay to have a negative exponent, okay? But other than that, if I don't see a times 10 to some power in your problem, I don't want to see a negative exponent, okay? You need to write it in the proper form. Okay, so now here's the rule for scientific notation. This number right here, A is a number. And it's got rules right here. So it says that the absolute value of A has to be greater than or equal to 1, but less than 10 at the same time. Okay? So, greater than or equal to 1, but less than 10. All right, so let me show you what I'm talking about because you're probably sitting there going, huh? All right, first, here's some rules about scientific notation. I have a tough time sometimes understanding the rules, so you are welcome to read through these if you want, but I'm about to show you my way. And my way, although is very, 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 very similar to this, I feel like it's just the way I understand it. So if you want to write this down, you're welcome to hit pause, but I'm about to show you how I do this. Okay, here's the Stacy way. What I do is I ask myself, where in this number of 37,000 could I put a decimal that would give me a number that is greater than or equal to 1, but less than 10, okay? If I put a decimal here, I have 3,700. That doesn't help me. If I put the decimal here, I have 370. Again, greater than 10. If I put the decimal here, I get 37. That's still greater than 10. But look, if I put the decimal here, I get 3.7. Well, that is greater than or equal to 1 and also less than 10 at the same time. So I want my decimal between the 3 and the 7. Okay, let's write that down. Okay, now ask yourself, does this number right here need to get bigger to turn into that? Or does it need to get smaller to turn into this number? And the answer is it needs to get bigger, right? If you say the word bigger, then that means that your exponent, this thing that goes right up here, needs to be a positive number. If you said smaller, that this number has to get smaller to turn into this, then that means this number up here has to be a negative number, okay? So since we said bigger because we want 3.7 to turn into 37,000, the exponent is going to be positive. And now you have to ask yourself, positive what? Well, how many places does it have to move to go from here? And remember, your decimal is actually right there in the original number. So it has to move to the right 1, 2, 3, 4. There we go. That's our number. All right, so in this one, where would we put our decimal so that the number is between 1 or equal to 1, but less than 10? And we would put it right here between the 5 and the 2. So I'm going to write 5.2 times 10. Now our exponent, remember the number that goes up here, is going to be negative this time. Why? Because 5.2 is actually going to become smaller, okay? And how much smaller? Well, let's see here. 1, 2, 3. So negative 3 is our answer. Or 5.2 times 10 to the negative third power is our answer. All right, again, these are some rules. If you want to read through them or write them down, go ahead and hit pause. I'm about to show you the Stacy method. All right, so 6.2, and we have a positive exponent, right? Positive means that this number is going to get bigger. Bigger means we're moving the decimal to the right, okay? So I want to move it 3 places to the right because that's where that 3 comes from, right? So I move it 1, 2, 3. Macy. That's Macy. And my decimal is right here after this second 0, okay? So my actual final number is 6,200. All right, so now we've got 8.9, but this guy is a negative number. That means that this decimal is going to move to the left 2 places, 1, 2, and so I need to fill in the values with zeros, and so this would be 0.089. All right, so what if you have to multiply scientific notation? That's okay. It's okay. We don't really distribute with this. So I don't want you to distribute, okay? Multiply the constant terms out front. 4 times 2 is 8, okay? And then we're going to multiply our scientific notation numbers together, and you get 10. But remember, since they have the same base, we add our exponents together, and there we go. 8 times 10 to the negative 2 power. And we're done. Why? Because this number is between 1 and 10, so we're good. All right, so what if we're dividing? Well, we use the rules for division then. So we do 9 divided by 3, which is 3. And then we have to subtract. So we've got 10 to the 3 minus negative 2, which really is 3 times 10 to the 5th power. There we go. We're done. All right, so that's it for this video. I hope you enjoyed it, and let me know if you have any questions.